Be equivalent to the sine of 22 degrees. Nick? Excellent. It would be the equivalent of the cosine of 68 degrees. Why? Why does that happen? German? Because 22 and 68 add up to 90 degrees. Very good. If you take the sine and the cosine of two angles that are complementary, they will equal the same amount. Okay? What about the cosine of 56? What will that be equal to? Bella, what'd you get? Yes. Yep. Oh, you didn't do it. Well, let's figure it out. So I said that the sine of one angle is the same as the cosine of its complement. There you go, 34 degrees. And for number 5, Cody B. Sine of 75 degrees, okay? Guys, keep in mind, every time we're given a cosine, we're comparing it to the sine of a different angle. Every time we're given the sine, we're comparing it to the cosine of a different angle. Do you guys see that? The sine of 15 is not equal to the sine of 75, right? You have to change the trig ratio that you're talking about. All right, before we get started, let's watch the announcements. All we're doing, we're not learning anything new. We're just going to be using what we have to what's called solve a right triangle. And to solve a right triangle, that means you have to know every single angle, every single side. So we're not done until everything has a place, right? But you'll always know one of the angles. What will one of the angles always have to be? 90 degrees, okay? So that one will be a gimme, right? You'll have to have one angle which is 90 degrees, all right? Okay, so first, let's refresh our memories with the inverse tangent, the inverse sine, and the inverse cosine, right? Those are used to help you find the angles of your triangle, right? So this is when you are missing an angle. You always want to use the inverse of the trig function. Because you can take the inverse tangent, cosine, or sine of the ratio of two sides, and it'll give you back the angle that you're looking at, okay? And remember, guys, it's expressed as tan to the -1 for tan inverse, or the inverse of tangent. It's expressed as cosine of -1 for the inverse cosine, and it's expressed as sine -1 for the inverse of sine. Okay, so if you know the lengths of two sides of a right triangle, then you can determine the third side and the two acute angle measures. How is this done? I want to do it with an example. So let's draw a right triangle where we don't know any of the angles other than the 90 degrees. But we do know two of the sides. Let's say this side is 4 and this side is 5. Very good, Zach. Zach already knows, because he's very good with his Pythagorean triples, that missing side has to be 3. Let's say, you're correct. Let's say we didn't know right off the bat that this was a 3, 4, 5 triangle. What could I do to find the missing side of 3? The Pythagorean theorem. So let's use it, okay? So what could I set up the Pythagorean theorem with? Remember, the Pythagorean theorem is a squared plus b squared equals c squared. Okay, make it x, okay. 4 squared times x squared equals 5 squared. Close. So you changed something that I don't agree with. Who said that? Plus. Very good. It should be a plus sign there. Okay, excellent. All right, let's keep solving. What do I do next?
You square it.
Okay, what's 4 squared? 16 plus x squared equals, what's 5 squared? 25. What do I do next? Subtract the 16 over. What do you get? X squared equals 9. Then what? Take the square root of both sides. So you're going to get x equals 3. So Zach was absolutely correct. Our missing piece has to be 3. okay? So remember, guys, you don't have to have the Pythagorean triples memorized. You can always solve for that missing side by using the Pythagorean theorem. But we still don't know anything about our angles, okay? But we do know all of the sides. So we're going to pick an angle, either the top one or this one on the left. Let's give them some values. So let's say this is going to be angle A, and this will be angle B. That's hard to see for you guys, isn't it? Is that better? Okay. So let's start with angle A. The cool part is we know all of the sides, so you can literally use whatever trig ratio you want. Which trig ratio do you want to use for letter A? Okay, let's use the tangent of angle A. What will be the tangent of angle A? What ratio will that create? Very good. Why is it 4/3? Someone explain that to me. Why would the tangent of letter A be 4/3? Juliet? What's that? Excellent. The 4 is opposite the A, and the 3 is adjacent to the angle A. Do we all see that? What questions do we have about this? Are we okay so far? Now comes the issue. We cannot solve this with the general tangent function. What do we have to use? The inverse tangent. Very good, Hayden. So I'm going to take the inverse tangent, or the tan -1 of both sides. And when I do that, what happens? What's the significance of taking the inverse tangent?
It crosses out the tan on both
It cancels out a tangent, right? They're inverses of each other. So A is just equal to the tangent inverse of 4/3. And when we plug that into a calculator, the inverse tangent of 4 divided by 3 is 53.1. All right, now let's not overcomplicate things. If A is 53.1, is there a very easy way to find what angle B would have to be? Do 90 minus 53.1. 90 minus 53.1. I believe that gives me 37.9, or no, 36.9. So angle B must be equal to 36.9. And both of these need what units next to them? A degree symbol, because they're both angles. Bingo. All right, so you're going to be given, now the cool thing is they can give you any two pieces of information. They could give you an angle and a random side. They could give you two sides. They could give you both the angles, okay? And then you would be asked, okay, figure out what, excuse me, they cannot give you both the angles. You won't be able to figure out what the sides are. They have to give you at least one of the sides, okay? And you're going to be asked, okay, figure out what all the other pieces are, okay? So that's all that 9.6 is. It's not anything new. It's just using everything in our toolbox now to solve right triangles. Let's take a look at an example, right, where we don't have a picture. Draw a diagram showing a person who is 1.5 meters tall, standing 20 meters from the base of a building. Let's draw that diagram. So we're going to draw a little person. How tall did it say that they were? 1.5, and I think it was meters, right? Okay. And they're standing 20 meters from the base of a building. So let's go ahead and say this distance here is 20 meters. And then we have our nice building with windows and a door. Also in your diagram, show that the person sights the top of the building with an angle of elevation of 58 degrees. Find the height of the building. So we're going to say, okay, he's looking at the top of the building at an angle of 58 degrees. Now, is he looking directly from the ground? No, he's looking from the top of his height, right? Because you look with your eyes and your eyes are at the top of your body. Do you guys agree? So we're going to draw another line like this to indicate, okay, he's that high above, like that's his comparison to the top of the building, right? Which angle? I know that this one over here, the angle of the building is going to be 90. But which of these angles is my angle of elevation? The one by the person or the one by the building? The person. Because do you see how this angle is going up?
Yes.
It's an angle of elevation. Does that make sense? What questions do we have on this? Identifying the angle of elevation. No? None? Okay. And how much was the angle of elevation? 58 degrees? Okay. So remember, we know that this is 20 meters. And we're looking for the height of the building, right? So let's go ahead, let's label this H. Let's try to find the height of the building. How would we do that? Ooh, who's at tangent? Hayden, very good. Why am I going to use tangent here? Huh? We have the opposite side, very good, which is H, and we have the adjacent leg, which is 20. So we are indeed going to use tangent. So I'm going to say the tangent of 58 degrees is equal to what? H over 20. Very good, Zach. Remember, opposite goes over adjacent. You are absolutely correct. All right. Who can solve this for me? Because we're solving for H. Juliet? There you go. This is one of the ones where we just multiply both sides by 20. And we're going to get 20 times the tangent of 58 degrees will equal, these 20s cancel, and you just have H. Plug it into your calculator. Let's see what we get. So we have 20 times the tangent of 58 degrees. 32. So H equals 32, and I believe it was meters, correct? What we just found is almost the height of the building. We almost found the height of the building. Does anyone think they know what we need to do to find the actual height of the building? Anja? Very good. You didn't add the height of the person looking at it, which was 1.5. Remember, this space right here we said was 1.5. So the full length of the building is going to be 32 plus 1.5, which gives me 33.5 meters. And this is our final answer. Okay? And guys, it'll be very obvious. If they ever want you to account for the height of a person, it'll give you the height of the person, right? If it doesn't tell you how tall the person is, right? Then you can assume that their height is negligent, right? Doesn't matter in terms of the problem, right? If that building was 1,360 feet or meters tall, right? Then the height of that person looking at it isn't going to affect it that much, okay? But if it ever tells you in the problem, hey, this person looking at it is like a meter tall, you have to use that at the end of your problem, okay? What questions do we have on this example? Yes?
Why do we not use a negative tangent?
Inverse tangent? Because we use inverse tangent, Ronnie, if we're finding an angle, right? We knew what the angle was. We knew that the angle of elevation was 58 degrees. What we didn't know was the height of the building, which is the side of the right triangle. Good question. Yes?
So you know how you multiplied 58 times 20?
You know how I multiplied 58 times 20?
Yeah, so like when they canceled out.
Yes.
Why would you put the 58 over 1 and cross multiply?
You could. So you could put 58 over 1, right, and cross multiply. You're going to get H equals 20 times the tangent of 58, correct? So it's the same thing either way, all right? Yes. 58 minus 90. Oh, yeah, and then you could get this angle, which would be 32 degrees, right?
Yeah.
You could totally use that, but then you'd have to use the tangent of 32 degrees equals 20 over h. So your ratio would change because you're looking at a different angle. Okay? Good questions. Yeah, Hayden. Sure. When the sun's angle of elevation is 28 degrees, a building casts a shadow of 45 meters. How high is the building? So let's draw our picture. We first have a sun. So draw a sun. It says its angle of elevation is 38 degrees. That means I start at the ground and I go where? Up. So draw an angle up towards the sun. And how much is that angle again? 38 degrees. And then we have to draw a building. And that building casts a shadow of 45 meters. So here's my right angle. Here's my my right triangle, excuse me. Which side of my right triangle is going to get the 45 meters? Remember, where would the shadow be of the building? Yeah, to the left on the ground. Do you guys agree? So this piece right here has to be 45.
Pardon the interruption. Sebastian Gonzalez, report student services. Sebastian Gonzalez, report student services.
And it wants to know how high the building is, okay? So let's put an X over here. What trig ratio could we use to solve for X? Yep, we can use tangent again. Why can we use tangent? Someone else tell me why we can use tangent. Nick? We have the opposite and the adjacent. Very good. So the tangent of 38 degrees is going to be what ratio? X over 45. Very good. Hey, question, Ronnie. Are we going to use the tangent inverse here? Why not? Trying to find a side. Okay, so we're just going to use standard tangent. How do I solve for X here, people? Multiply by 45. Excellent. These are going to cancel. So we get 45 tangent of 38 degrees equals X. Plug it in. Let's see what we get.
35.2 meters.
45 times the tangent of 38. 35.2 meters. All right, guys, this is where we're going to pause.